Hey AP Calc students, welcome to day 8. Today we're going to be looking at writing tangent line equations. It's going to build off of our power rule, but it's going to be just a little bit different. We're going to be writing tangent line equations, and we're going to talk about average rate of change. Now, you learned about average rate of change in those AP daily videos, but I just wanted to get it one more time so it's good and in your notes, so I can check on that. Okay, so let's talk about writing tangent line equations. First off, we're talking about a tangent line. Okay, so we're drawing a line here. Things to remember. I want you to think about this. What is needed for an equation of a line? Okay, well, there are really only two things that we need. We need to find a point, and we need to know a slope. Okay, once we know the point and the slope, we can easily write an equation of a line. So, for example, we talked about this in in class earlier, but just as a reminder, let's say I have a point 3, -7, and I have a slope of 4. Okay, I could write an equation of a line by simply doing y minus that y coordinate equals the slope times x minus the x coordinate. Okay, because I know this point is the point xy. Okay, now I'd probably write this as y plus 7 equals 4 parentheses x minus 3. And either one there, either the one I wrote above it or the one I circled, would be a good equation for that line. Well, when we write equations for tangent lines, that's where derivative comes into play, because the derivative is the slope of the tangent. So if I told you that f prime of a equals m, that means m is the slope of the tangent line at x equals a. Okay. So if I told you f prime of 3 is 10, that means when x is 3, the slope of the tangent line would be 10. Okay? So using that, let me show you an example of a problem that you might have to solve. So here's an example problem. I'm telling you f of x equals 10 root x. And I want you to find the equation of the tangent line to f at x equals 4. Right? So if we took a graph of this 10 over root x, right, it's a curve. And at x equals 4, there's a tangent line. Okay, so let me just show you on Desmos here what this graph looks like. So again, if f of x equals 10 over, by the way, Desmos is a great free tool. If you just go to just Google Desmos, you'll find it. For square root, I'm just gonna, if you just type SQRT. So here is this curve, okay? So this is what this graph looks like. Obviously, we have a domain here of x must be greater than 0, because we can't do square roots of negative numbers. We can do a square root of 0, but it puts 0 in the denominator. Right? So we see that vertical asymptote here. So we just see this curve here. and we're focusing on x equals 4. So what we want to do is come up with an equation for a tangent line right here at x equals 4. Right? I can tell it's probably going to have a y-intercept somewhere up here. I can tell it's going to have a negative slope, okay? And it's got to go through this point, but it shouldn't go through other points around it to make a tangent line, okay? So let's go ahead and see if we can solve this and graph that line and see what we see. Okay. So whenever I ask for an equation of a tangent line, okay, not just the slope of a tangent line. If it's the slope of the tangent line, I'll show you that in a little while. Here we see we want an equation of a tangent line. The first thing I want you to think is, okay, I need a point and I need a slope. Because to write an equation of a line, I need those two things. Now, part of the point is given to me, right? The part of the point that's given to me is right here. The x part of the point is 4. But I need to figure out the y part of that point, or the f of x part of that point. Okay. Any ideas on how we'd find the y coordinate, right? The f of x coordinate? Well, it's pretty simple. We can just use our function right here, f of x, right? And I can find f of 4 pretty simply by just plugging in 4 for x. And I'll see that the y coordinate of that point is 5. Okay? So by plugging in my x value into my function, f of x, I can find the y coordinate of the point there. Okay? But the next thing I need is slope. Right? You could have done this in probably algebra 1. Okay? Slope of the tangent line is where the calculus comes in. Okay? Derivative means slope of the tangent line. And now the slope of the tangent line is different depending on what x value we're looking at, right? When I go back to that graph there, I see really steep tangent lines as I get closer to 0. I'm going to see more flatter ones as I get bigger x values, right? They all appear to be negative. Okay, but I want to know the slope of the tangent line specifically right here at x equals 4. Okay, so what I'm going to have to do then to find the slope of the tangent line, right? I need to figure out what f prime, right? The derivative f prime of 4 is. But I told you today in class, before you find f prime of 4, always first find f prime of x. And to find f prime of x here, I'm going to have to use the power rule. But I'm going to have to rewrite it, right? This is not 10 over root x is not in ax to the n form. So I'm going to rewrite f of x up here. And I know that square root means half power, but it's also in the denominator. So I'm going to rewrite f of x there as 10x to the negative half. Now it's in ax to the n form. Again, it's half because we have a square root. It's negative because that square root was in the denominator, right? So if you think about it in 2 steps, I could change this to half. And then when I move it up to the numerator, I switch it to negative half. Let's figure out f prime of x first. F prime of x, then, I would use the power rule, and I'd multiply my exponent, which is negative half times 10. Negative half times 10 is negative 5. And I have to think about my new power. Well, I have to do negative half minus 1. But again, when I subtract fractions, I want to make sure I have a common denominator of 2 there. So negative 1 minus 2 is negative 3, so I get negative 3. Okay. So that's f prime of x, but I don't want to plug 4 in when I'm in this form, because without a calculator, 4 to the negative 3 halves can be a little tricky. So let's just take, right, this x is to a negative power. I'm just going to move it into the denominator, leaving negative 5 on top. And I'm going to call it x to the positive 3 halves. And I'm going to make one more substitution here, or one more rewrite. I'm going to call this negative 5 over. Again, this is the type of root, so it's a square root of x cubed. Okay. So I'm going to take the time to do that rewrite before I find f prime of 4, because now finding f prime of 4 should be very simple. Okay. So f prime of 4 then, I'm just going to replace the x with a 4. I'm going to have negative 5 over root 4 cubed. Now you can do this in either order. You can cube the 4 and then square root it, or you can square root the 4 and then cube it. It's much easier without a calculator to do the root first, then the exponent. Well, I know the square root of 4 is 2, and I know 2 cubed is 8. So I get f prime of 4 equals negative 5/8. That's the slope of that tangent line. Now, the slope here ended up coming out negative, which I anticipated. I was hoping it would, because I can tell by the graph that our slope should be negative. Now, the last thing I have to do here, right, is write the equation of the tangent line. Well, this part's really easy. I can just do y minus the y coordinate equals the slope times x minus the x coordinate. And here is the equation of my tangent line. Now, if you wanted to graph this on your graphing calculator, the one thing you'd have to do is take this minus 5 and add it over, because your calculator always starts as y equals. But on Desmos, you don't have to do that. So let's see what happens on Desmos when I graph this. So I'm just going to graph this exactly how I wrote it. Y minus 5 equals my slope of negative 5/8, parenthesis, x minus 4. And look at that. Beautiful, right? I see a tangent. Here's f, and here's my here's the tangent line I wrote. Notice how it makes just a perfect tangent line right there at the 0.45. Okay? Notice how it matches the slope of the curve exactly at that point. Okay, so Desmos is kind of a way that you can check yourself to see that you're doing it correctly. All right. Good. So let's go back and take a look at one more type problem. Okay. Now, when you look at this, you might say, hey, this is exactly like the question before, but it isn't. Okay, here's where you need to be careful. Notice in this question, I asked for the equation of the tangent line. In this question, I simply asked for the slope of the tangent line. Okay, so I don't need an equation of a line here. I don't need to find a point and a slope. I certainly could. All I have to do is find the slope of the tangent line. Okay. When we read this question, our mind immediately needs to go to, I want the slope of the tangent line to f at x equals 3. Immediately you need to think, this means I want f prime of 3. That's my ultimate goal, find f prime of 3. Okay? But before we find f prime of 3, we must find f prime of x. And before we find f prime of x, we must rewrite f of x. F of x is not in ax to the n form. So let's rewrite f of x. Please note here that I'm calling it f, not f prime. I'm not doing the derivative yet. I'm just rewriting f of x. And again, I'm taking that x squared in the denominator and moving it up to the numerator. To do so, I must adjust with that little negative sign. Okay, so I rewrote f of x. Now I'm ready to do f prime. And I got negative 14 x to the negative 3. And because I'm going to be plugging in the number 3 here, I don't want to do 3 to the negative 3 power. I don't want to work with negative exponents. So I'm simply going to rewrite this. I'm going to drop that x to the negative 3 into the denominator, leaving the negative 14 on top, and switching that exponent to a positive 3. Okay. Now when I want to find f prime of 3, it's very simple. F prime of 3 must be negative 14 over 3 cubed. Please don't tell me 3 cubed is 9. I see that way too much. 3 cubed is 27. And there I have it. All I asked for was the slope of the tangent line to f at x equals 3, and there is my slope. Now, if I wanted to find the equation, I could do so very simply. I would just have to get the point, right? So all I needed was the slope. I could, if I wanted to, get the point, but they didn't ask me to, so I'm not going to do it. Okay, average rate of change, and then we're done. Okay, so the average rate of change of any function on an interval a, b, I'm just going to put this in a formula. You guys solve these problems on multiple choice, okay? But an average rate of change of f on a, b always equals, which is the slope of the secant line, f of b minus f of a over b minus a. Okay, and this is our equation for average rate of change. Now we could do this with functions, we could do this with tables, we could do this with graphs. Right? On a graph, I might see something like this. Let's say this is the point 2, 1, and this is the point 6, 6, 6. So this is the point 2, 1. This is the point 6, 6. I want to find the average rate of change of this function. It is simply going to be the slope of the line that connects these two. Right? So average rate of change here, I'll call this function f. Our average rate of change of f on this interval here, it's going to be on the interval 2 to 6. Right, that's like my A and my B here. This will be f of 6 minus f of 2. Right, this is like my A, this is like my B. F of B minus f of A over B minus A. Right, f of 6 we know is 6. F of 2 is 1. And 6 minus 2 is 4. So I get an average rate of change of 5/4. Now, when they ask you to do that, they want you to provide a difference quotient. So they want to see a quotient with subtraction, right? This big fraction bar with some subtraction in there as well. Okay. Now, when we see a function, say we have a function f of x equals 3x squared plus 1. What is the average rate of change of f on, let's say, the interval? Let's make it something that's easy to calculate. 0, 4. Okay, so again, I want to do my f of b minus f of a over b minus a. Here's my a, here's my b. So my average rate of change would be f of 4 minus f of 0 over 4 minus 0. That's all you do. Okay? But we're going to have to plug this in to figure out what f of 4 is and what f of 0 is, right? We were able to get those easily from the graph by just reading it. Okay? But here we're going to have to plug in. So f of 4 would be 4 squared, that's 16. 16 times 3 is 48. 48 plus 1 is 49. F of 0 is 1. Over 4 minus 0 we know is 4. Now they talked about this in the video, the AP daily video. Okay, but if this is a free response question on a test, feel free to just circle this answer. Okay, once you have a numerical answer, you can circle it because it's done. Okay? This is not numerical because it's got the f of 4 and the f of 0. Okay? Now, if it's multiple choice, they're never going to leave it as 49 minus 1 over 4. They're going to say 49 minus 1 is 48. 48 divided by 4 is 12. So we need to be able to simplify it for multiple choice purposes. But if it's a free response, just circle your answer once you got it in all numbers. Okay? Last case where we see this is tables. So let's say we have some function f of x. We don't know what it is, but we have this table. Right? I have no idea what's going on anywhere else on this function except for those 4 points, 0, 5, 2, 10, 4, 18, and 6, 15. They might say, what's the average rate of change? Of f on, let's say that we say 2, 6. Well, again, this is very simple. This is our A. Our B. We'll simply say, okay, well, this is going to be f of 6 minus f of 2 over 6 minus 2. Well, that is not a numerical answer yet, but now I can just go ahead and figure out what f of 6 and f of 2 are. By the table here, f of 6 I can see is 15 minus f of 2 is 10 over 6 minus 2. Yeah, you can leave it 6 minus 2, or you can say that's 4. You can go ahead and circle here, or you can simplify it out to 5/4. If it was multiple choice, you'd want to do that. Okay, that's it for today. I'll see you guys in class on Thursday. Talk to you later. Bye.